Hi, so this is a screencast of your elaborate on your energy bar charts. So you just went through a presentation on how to do the energy bar charts and where they come from. The first thing I recommend you doing is reading this link right here. That link is going to give you some information about the phase energy and the thermal energy and how you're going to incorporate this. The most important thing to know is that energy is going to be conserved. We're making sure that we're following the second law of thermodynamics, which states that energy is not created nor destroyed. It's just going to shift form. So what I'm going to do is I'm going to walk you through question number 1 and number 2 on this worksheet. When you open up this worksheet, it will actually be done for you. That's the copy that I'm going to put in your assignment. But what I want to do is I want to do those and show you how I did them so that that can help you with the rest of the activity. So right here, I have included bars. I have 4 bars, I have 3 bars, 2 bars, and 1 bar. And then here, 4, 3, 2, 1. So I made my thermal energy red. I made my phase energy yellow. Okay. And then I also have a negative Q and a positive Q. So here, negative Q is heat leaving. That's what negative Q is. So negative Q is an exothermic process and positive Q is an endothermic process. And another thing that I've done with all of these images is I've made sure that these images are going to be able to have the wraparound text. Okay, so what I'm going to do then is I'm going to take these images and then I'm going to copy them as I need them. So I've only made 1 copy of each for you. It's very important you copy and then go in place. So looking at question number 1, it says a cup of hot coffee cools as it sits on the table. So you could make that 4 bars or you could make that 3 bars, okay, for starting off with, because it's hot. So I'm going to say that it's like super hot. Maybe I'm someone who really likes to drink my coffee very hot. So I'm going to copy that, and then I'm going to go ahead and paste another copy of that, and I'm going to move it down here to my thermal. Okay, and so I'm showing that I have hot coffee and it sits on the table, and what's going to end up happening? It's cooling to room temperature. So then I'm going to take my room temperature, which is 3. I'm going to make a copy of that, and I'm going to paste that down here. I'm going to move that to my thermal energy afterwards. So that's showing that my thermal energy went from high and went to low. Then I'm going to look at my phase energy. My phase energy here is going to be liquid. So we talked about this, that solid is going to be 1 bar, liquid is going to be 2 bars, and gas is going to be 4 bars. So we actually don't need the 3 bars, but I have coffee in the beginning, I have coffee in the end. So I have liquid in the beginning and I have liquid in the end. So in the very beginning, I have my 2 bars. So I'm going to copy and then paste. Okay, for my phase energy. And then I'm going to do the same thing. So I'm actually going to paste again for my phase energy afterwards. Okay. Now, chemical energy. We are not going to concern ourselves with chemical energy because we're not going to look at chemical energy until the kind of the end or the middle of second semester. Okay. So what I'm going to do then is I am going to write my explanation, but I'm going to write my explanation after I talk about my energy flow. So what's happening? My thermal energy. So I'm going from 4, 5, 6 bars. So I'm going from 6 bars. So we can say initial has 6Q. We'll just call it Q for right now. And final has 4Q. So the coffee has lost 2Q. the particles get closer together. And why is that? The particles get closer together, and the particles start moving slower. Okay, they slow down, they get closer together, not super closer together because they're still liquid, but they're going to do this because they're losing energy. Okay, and so again, so I'm losing energy, so I'm going to use my negative Q. I'm going to make a copy here, and I'm going to bring it over here, and I'm going to paste it, and then drag it over, and there you go. So this is what an energy bar chart looks like. I have my thermal energy goes from high to low. My phase energy doesn't change because I'm staying as liquid. And that's going to be my very first energy bar chart. Now I'm going to scroll down to my next one. And my next one says that I have a tray of ice cubes. A tray of ice cubes is placed on the counter and becomes water at room temperature, 20 degrees Celsius. Now, because I have a tray of ice cubes, it's ice, it's solid. So I'm going to start with my phase. I start with a solid and I end with a liquid. So I'm going to take my solid, which is going to be my 1 bar. I'm going to bring it down here, copy and paste. Take this and I'm going to put it in my phase for, so I accidentally got that. I'm going to put this in my phase for my ice. Okay. And then I'm going to go back up and I'm going to get my liquid. So my liquid is 2 bars, remember? So I'm going to copy. I'm going to paste it down here. Okay. And then I have ice, which is -8, goes to room temperature. So I was not able to make something smaller than this single bar. So you're going to have to use this single bar for 0 degrees and below, unfortunately. So I'm going to have that come over here. That's going to be my -8. And again, if you were drawing this, you would probably want to make it less than that 1 bar, but it's what we have. And then for my room temperature, I'm going to have my 2 bars. So I'm going to take that. I'm going to bring it down here. And I think that the best way to do this is to write my explanation first and then to put in my Q values. So my explanation is going to be that my initially I have 2Q, and in the end there are 4Q. The ice gained 2Q. The particles got farther apart and started moving faster. You could also even say because they gained 2Q, this is an endothermic process. Okay. Particles get farther apart. Okay. So because they gained Q, I'm going to have a positive Q. So I'm going to make a copy of this. And I'm going to move it over here. It's important to click on the side first and then drag it. Okay. Show that you have your plus Q. And that's what your second bar graph is going to look like. So you have your explanation, you have your bar charts, and you're good to go. So you're going to go to the next one. Now I want to scroll through this document so that you can see what the document looks like originally, just because if things kind of move around, you can see where you can shift things so that the graphs are aligned. So the next one is going to be a can of soda. Cold soda warms as it's left on the counter. And then you have a question, where does that energy entering the system come from? You spill water on your shirt and it evaporates. That's going to be your next one. Water vapor in the room condenses to a liquid. And then you're going to have, this is going to be an honors question. A pan of water, 25 degrees Celsius, is heated to boiling, and some of the water is boiled away. Do separate energy bar charts for each stage. So remember, there are two different stages here. You're raising the temperature to your boiling point, and then you're boiling it away. That's a phase change. So then what's that going to look like for the bar chart and for your explanation? And then here is a question about your boiling water. Okay, what's inside of the bubbles? Why do you think so? And then this last question, everyone's going to see a question similar to this. What is going to happen to this curve right here if I increase the amount of substance? Now, this is going to lead into your final project for this unit, which is going to, you're going to be working on that on Friday. So I hope that this helps you. Let me know if you have any questions and I can answer them. So email me at spalachek@guhsd.net, or go ahead and set up a meeting with me and I can meet with you.